Okay, why only one? Where are the others? Please join now. Sel, Sel, kontrol lang iro, Sel. Kaya nagklase ko, Sel. Sel, kontrol lang iro, kaya nagklase ko. Isarado sa gabi, isarado ni. Close it, close. Okay. Hello? Hello? Only one? Only one join? Or didn't know how to use Discord? Ay, nako. Okay, I will open in Zoom. Maybe Zoom it, you are not used to it, no? Lark it. Hello? Hello, can you hear me?
Yes.
Only one? How many are here? How about Chanuchida, Ramidsuda? Can you hear me?
Yes.
Yes. Only seven. Where are the others? Okay. Is it okay here or are we going to Zoom? Okay. We have only seven. Please. Okay, we can start now, no? Did you see my screen? Hello?
Yes.
You can see my screen, right? Okay. I will message first to the others. Wait. You can. I check first if you can access on YouTube. Okay, we are about to start. We are about to start. Okay. Uh, okay, we are about to start. Okay. Hello? Do you hear me? How many are you here now? Hello? Please unmute your mic so that I can hear you. Hello?
Yes.
Only one?
Hello.
Only one? There are seven, right?
Yes.
Just Panas, just enter a new meeting, and then you can type the password, the code. Okay? I know it's a little difficult because it's the first time to use, but this one is we will not able to cut, no? Like not like in Zoom, they're gonna cut in 30 minutes. Okay, can you see my screen? Hello?
Yes.
Only one. How about the rest? I don't know. Can we, can we go to Zoom? It's not good here, right? Okay. We go to Zoom, we go to Zoom. I think this one uh, cannot use here. This one here is you have only Discord enter. Chanuchuda, did you hear me? Chanuchuda.
Yes.
Okay. Mochu Chayan 1. Wasin, can you hear me?
Yes, I can hear you.
Pop, can you hear me? Okay. Okay, unlock first your mic so that I can okay. You can unmute your mic please so that you can I can talk to you then you can okay? Okay, I can share to you my slides now. We can start now. Okay, can you see my screen, all of you?
Yes.
Hello.
Yes.
Okay. Now we start with the pre-test. This is our lecture 2. We will start with the pre-test. Okay. Uh, the first question is define science. Okay. Junior, what is science? How do you remember science in our last meeting? Hello. Okay. This Discord. What is science in our last meeting? Please unmute yourself. Hello. Discord. Okay. Science is the knowledge gained through conclusion made using deductive reasoning that is based on observation and experimentation. In other words, science is a knowledge, no? You gain through conclusions. If you after you gain, you make a conclusions, then you use deductive reasoning. That's why they use observation and experimentations. Okay. How about chemistry? Do you know what is chemistry? Hello?
Em lúc này á.
Chemistry. Okay. Chemistry. What is chemistry?
ไม่รู้ต้องไปดูที่ไลฟ์ต่อ
Okay. Milo, ah. Okay. Chemistry is what? Is a study of composition,
ไม่มี
structures, and
ไม่รู้เลย
properties of matter that changes matter undergoes. Last time I discussed to you, chemistry is a composition. You know, the word composition means what are the components? Example, air. What is the, what is the component of air? Is a study of composition, structures, and properties of matter that changes matter undergoes. Okay. Do you understand? Okay. I cannot see the other one. The other one. Okay, participants, did you hear right? Pop. You heard me right? Okay. If I call your name, just unmute yourself in the control. Okay?
okay. Sorry.
Okay. Now, what type of substance do chemistry work with? Okay. When we say Again, chemistry is the study of composition. Composition means to say, like water, the component is hydrogen and oxygen. Like air, the component is what? Nitrogen and oxygen, right? Those are composition. When we say structure, structure means the structure of water. You see, no, there are two hydrogen in one oxygen. Okay, properties of matter. What are the properties of water? Okay, you have a liquid, sometimes become a gas. Those are properties. So, and then the changes matter undergoes. If the water, there are changes of water, it becomes solid, it becomes liquid, it becomes
โอ้แล้ว
gas.
ทำไม
Okay,
ชื่อแบ
that's
บอ
why
ย่างนั้นเยอะเนี่ย
we study about defining chemistry. Now, what type of substance do chemists work with? Okay,
แม่ปิดไมค์ก่อน
chemicals, right? What type of substance do chemists work with is our chemicals. That's why chemists work with the chemicals. Chemical example, those are chemical like oxygen, nitrogen, all that you can find in the periodic table, and compound like salts are chemicals. Oh, this is the chemist's work. They are working with chemicals. Okay, reviewing with our last lessons. Okay, name 6 branches in the study of chemistry. What are the 6 branches study of chemistry? We have, first one is organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, biochemistry, and theoretical chemistry. Okay. Chemistry. Okay. Then we have compare and contrast. Okay, how many branches of chemistry? There are 6, right? Organic, inorganic, physical, analytical, biochem, and theoretical. This is our lesson last time, right? Okay, compare and contrast basic research, applied research, and technological research. Now, last time we discussed about what is basic research, applied research, and technological development. If you have remember, basic research is conducted for the sake of knowledge and only and not to meet the practical goals. For the sake of knowledge only, okay? And then we have also applied research is conducted to meet goals to define specific needs. So applied research is to meet the goal and define what needs to be done, okay? And technological development is employ existing knowledge to make life easier or more convenient. It's like innovations to more convenient and accessible. Okay, you understand? Okay, next. Now today, our objective is we will define what is the word matter. Okay, matter. And then we will classify the compositions of matter. And then we will distinguish between the physical properties and the chemical properties of matter. Okay, these are 3, no, that we will, 4, I mean, sorry, the last one. We have classify and changes of matter as physical or chemical. And then explain the building blocks of matter. I don't know if we can finish it. Maybe we can finish 3 objectives today. Okay, first is we will define what is matter. Then classify the compositions of matter. And distinguish between the physical properties and the chemical properties of matter. Then we will classify changes of matter as physical or chemical. And then we will explain the building blocks of matter. Okay. Okay, I will ask to you. Let's say, Ramida, what is matter? Ramida, hello. Can you hear me, Ramida? Can you unmute, please, yourself? Ramya,
Yes. Yes,
okay.
but I don't know what is matter.
You don't know what is matter. Okay. You think remember in your science what is matter? Matter is what? Matter has a volume, right?
Yes.
Okay. Matter has a volume. What else about matter? Matter has a mass, right? And then
Yes.
matter is
Yes.
anything that has a mass and take up space. Do you understand, Rabida? Okay. Matter is anything, no? That if has a mass and then have a volume or take up space is a matter. That's why it's very simple. Matter has a mass and volume. Volume take us space, right? What is volume? It's the amount of three-dimensional space an object occupies. You know volume, right, Ramida?
Yes.
Okay. You know mass, right? Okay. Tunutida, can you hear me?
Yes.
Okay. Do you understand, right? Very simple. Now, matter has a mass and volume because this take up space is a volume, right? Anything that take up space containing a volume. Okay, I'll show you visual concept about matter. Okay, can you see, right? Okay,
Matter. Matter is anything that has mass and takes up space.
okay. Matter is anything that has mass and take up space. Okay,
Everything is made of matter. Matter is defined as something that has volume and mass.
okay. If you look at here, okay, you have a mass, and then this is a anything, no? Like the chalk, like the ball, like the fruits are all matters. This weighing scale are all matters. Okay. Okay, next we have an
Element. An element is a pure substance made of only one kind of atom. Carbon found in diamond is an example of an element.
okay, an element is a matter. It's a pure substance made up of only one kind of atom. Okay. Example of an element. Okay, carbon. Carbon can found in a diamond. Okay.
All elements are organized by their properties on the periodic table. All elements are denoted by 1, 2, or 3-letter symbols. The first letter of the symbol is always capitalized.
Okay, this is an element. No? It can be one letter or two letters, right? Okay, like hydrogen is a one letter. Okay, we have helium is a two letter here, and the first letter is capitalized. Sometimes have also a three letter symbol, like here, no? The new element that we can found here, new like the UUB are the three symbols. All of this we can find in the periodic table. This is part of the matter. Okay, what is a molecule? A molecule is a natural group of an atom held together by a covalent bonds. Water, oxygen, and sucrose or table sugar are examples of molecules. In other words, a molecule is like a compound, no? Like water, H2O. If you look at this model here, this is the model of the water molecule. If you look at here, we have two hydrogen here, the blue one, and the red one is the oxygen. So you have H2, 2 for hydrogen, and 1. This is an example of water molecule. Also, oxygen is a water molecule, is a molecule also. Why? Because oxygen in free state is a diatomic. You have two mass, no? Diatoms together. That's why you have O2 in free state. Sucrose, you know sucrose is a sugar, right? Sugar uh, we made to put in a milk or coffee to mix sweetening in our food. Now, sucrose have a formula of carbon 12, hydrogen 22, and oxygen 11. It means to say there are 12 carbon. The carbon here are the green one. There are 12 pieces of carbon bind together, and there are 22 hydrogen. You know, hydrogen is the small blue one here. These are the hydrogen, and the oxygen are the red one here. There are 11 oxygen. This is a sugar. This is example also of a sugar molecule. Okay, next, a compound.
Compounds. A compound is a substance that is made of atoms of two or more different elements joined by chemical bonds.
Okay, it's a substance that is made of atoms of two or more different element joined by chemical bond. So a compound example is let's say water, H2O is a compound. Okay,
A compound is a material made up of a group of atoms bonded together in a regular fashion in predictable numbers. The active ingredient in aspirin, for instance, contains many units or molecules that can be represented by the structures shown here. Each has 9 carbon atoms, 8 hydrogen atoms, and 4 oxygen atoms. If the molecule doesn't contain these elements in this arrangement, it isn't aspirin. Bonds hold the atoms in chemical compounds together. Compounds have properties that are very different from their original elements. In contrast to aspirin, which contains carbon, hydrogen, and oxygen, the elements hydrogen and oxygen are gases at room temperature. One form of carbon is the solid found in pencil lead.
okay. Let's say do you know this pencil lead here? You know, okay. This is made up of carbon, the black one here. Okay. That's why we have example of a compound, aspirin, right? A while ago we have an aspirin, we have a molecular structure of the aspirin. Also, carbon dioxide is an example of compound. You know carbon dioxide? Okay, it's an example of compound. Okay. 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 We know already that atom is the smallest unit of element that maintain chemical identity of that element. An element is a pure substance that cannot be broken down into simpler, stable substance, one made of atom. For example, we have hydrogen, oxygen is a pure substance. No? You cannot break down anymore. It's very simple already, and very stable. It's only one type of atom. And a compound is a substance that can be broken down into simple, stable substance. Each compound is made up from atom. Okay. Okay, I show you what is an atom here so that you will understand more.
Hi, I'm Emerald Robinson. In this What Is video, we're going to take a closer look at atoms. All matter is made of elements, substances that cannot be broken down by chemical activity. An atom is the smallest particle of an element that retains the element's properties. Atoms are the building blocks for everything in the universe, including ourselves. People often think of atoms as the smallest possible forms of matter, but even smaller particles make up atoms. Each atom has a dense center called a nucleus. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines an element's physical properties. No two elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract each other, so atoms usually have equal numbers of the two particles. Scientists assign atoms an atomic number and atomic mass unit. The atomic number is the number of protons present in the atom. For instance, a helium atom has 2 protons, so helium's atomic number is 2. Add the number of protons and neutrons in an atom's nucleus together, and you get the atomic mass unit, or AMU. A helium atom has 2 protons and 2 neutrons, so has a mass of 4 AMU. Electrons have almost no mass and are not included in AMU calculations. While an atom's number of protons remains constant, individual atoms can lose or gain electrons. Atoms with different ratios of electrons to protons are called ions. Atoms of the same element can also have extra neutrons. Scientists call atoms with extra neutrons isotopes. Despite having different neutron counts, isotopes retain their element's chemical properties because the number of protons remains constant.
For thousands of how-to and advice videos on any topic, visit monkeyc.com.
Okay. We understand already what is an element there, no? A molecules and a compound. Okay. To discuss much more. Okay. Okay. Now, okay, basic building blocks of matter. This is our basic building blocks of matter. We have a carbon atom here. This is the carbon atom here, right? These are the blocks of matter. If you look at microscopically, they are attached to each other. There are carbon and other carbon attached to each other. Okay. Another way to look at on this also is in this way. You know, we have here the oxygen, carbon, and the hydrogen. This is a hydrocarbon substance. Okay, these are the blocks of matter. Okay. Now, matter have its own properties. No? We have 2 kinds of properties of matter and changes in matter. The first property, we call it the extensive properties, depends on the amount of matter. Okay, we have volume. Volume is one of the extensive property of matter. Volume. Mass. Mass is one of the also extensive properties of matter. And then we have amount of energy. Amount of energy is a substance. In a substance is an extensive properties of matter. What is this extensive properties of matter? Extensive property, it means to say even changing the volume, but it's the same property. For example, the 2 liters of water is the same property or same component of 30 liters of water, like that. Huh? Or let's say in the mass, 2 kilograms of solvent is the same as 20 kilograms of solvent. Or that's also we call it extensive property. Even though there's a changes in terms of mass and volume or the energy, but the matter itself doesn't change. And we call that only extensive property. It means external changes, no, of the We call it external changes. The next is intensive property. Now, intensive property do not depend on the amount of matter present. Do not depend on the amount of matter present. Example, melting point. Melting point are, they change, no? Melting point of, let's say, melting point of water. No matter how many volume of the water, is still the same melting point. The same boiling point. Another is boiling point, right? When we say you have a metal, like let's say a metal, you have iron. No matter, let's say 2 kilogram of iron and 10 kilogram of iron, no matter they change already the mass, but they have the same melting point and the same boiling point. So these are intensive properties. We have melting point, boiling point, density, density, the mass over volume, and then the ability to conduct electricity. Okay, and then we have ability to transfer energy as a heat. Okay, these are example of intensive property. Okay, do you have a table here? Example of intensive property. Electrical conductivity is ability to carry electricity. For example, metal have an electrical conductivity, right? It can carry electricity. Example, copper is a good electrical conductor. So that if you look at the wire that we use in our electricity are made up of copper. No? It's look like copper is a combination, it's a metal. So it's a metal, right? It's look like a bronze, but bronze is made up of copper. That's why copper is a good electrical conductivity used in wiring. Another one is heat conductivity. When we say heat conductivity, is ability to transfer energy as a heat. Ability to transfer energy as a heat. It means to say he will accept heat, to his body and allow the heat travel to his body, transfer. Example is aluminum is a good heat conductor. When we say heat conductor, okay, so it is used to make pots and pans, right? That's why so that heat conductor is easy to be heated up, right? So a very very famous aluminum to make like the pans, pans, the frying pan we use in the kitchen, pots also. Okay, density is the mass divide the volume or mass to volume ratio of a substance, measured of how tightly matter is packed. That's why lead is a very dense material, so it is used to make sinker for fishing line. Lead is a very dense material. Dense means very heavy, right? Heavy. As it is used to make sinker for fishing line. So they use the lead not to sink the net of the fishing line, so that the net will be going down, so that it can catches the fish. So these are one example only of a dense material. Lead is one of the dense material. Gold also, gold is very dense material, no? Okay. Melting point. What is melting point? Temperature which the solid changes to become a liquid, no? From solid to liquid, we call that melt. Solid to liquid. Now different substances have different melting point. Example, ice. Ice is water, right? Ice melts to become liquid at what? At 0 degrees Celsius, right? Ice is negative temperature, that at 0 degrees Celsius it melts to become liquid. Okay, that's the melting point of an ice, 0 degrees. Okay, different substances have different melting point. For example, gold. If you want to melt gold, you need to have a high temperature, or high, yeah, to melt a gold, to become a gold, a liquid. That's why you need to heat that in the torch, in a blue torch, no? If you look at how they're gonna make jewelry, they're gonna heat it up the gold to deform again, to make in the casting whatever they want to make like a jewelry. Okay, boiling point. Boiling point is a temperature which a liquid boils and changes state to become a gas in a given pressure. Boiling means example of liquid water, right? It boils at 100 degrees Celsius. It means to say from liquid to become a gas, water vapor. That's why below 100 is still a liquid. more than 100, it become a gas for a water. That's why that's a boiling point. Example only. Different substances have different boiling points. Same with the melting point also. Another intensive property in another property is index of refractions. What is index of refraction? Extent to which a given material bends light passing through it. Okay, when you uh, when you pass the light, it bends the light. No? Okay, that's the index of refractions. The index of refractions of water tells you how much light slow and bends it passes through the water. Okay, sometimes if you look at now in the water, it look like you can get an object, but in fact it's very deep, right? That's why, because our water has an index of refractions. Malleability. Malleability is ability to be hammered or beaten up into thin sheets. Example, metals. Some metals are very malleable, no? Like iron sheets. It can make up like sheets, no? To make a roof. Okay, that's malleability. To make a thin sheets, like to when you hammered it, it can make a sheets, no? Sheets. Okay, silver is a quiet malleable, so it used to make jewelry. So it's silver, no? Silver is a quiet malleable. You can deform and reform again to make a new design or make new forms, right? The last one here is ductility. What is ductility? Ability to be drawn into a thin wire. You remember, like, you know the guitar, right? The guitar string or the violin string or the string that used in the musical instrument. Okay, that metal have a high ductility because he has to be ability to drawn into thin wire without breaking up, right? Without breaking up, I mean, without breaking up. It become a very small diameter wire, but still strong, right? One example is tantalum. It's very high ductile material. Tantalum is a ductile metal, so it is used to make fine dental tooths. It's used in the jackets and braces. That's a tantalum. If you have a braces and jackets in your tooth, the dental, they use that kind of metal as a tantalum. Okay. Now, I will show you today how we're gonna compare extensive and intensive property. Okay.
Comparing extensive and intensive properties. An extensive property depends on the amount of matter that is present. An intensive property does not depend on the amount of matter present.
Okay, very simple, the difference we talked to. Intensive depends on the amount of matter that is present. And intensive doesn't depend on the amount of present. Okay, show this one. Look at this one.
Extensive properties depend on the amount of matter that is present. For example, the volume of water in the small beaker is 25 milliliters, and the mass of that water is 25 grams. The volume of water in the large beaker is 100 milliliters, and the mass of that water is 100 grams. Intensive properties do not depend on the amount of matter present. For example, at standard pressure, the boiling point of water is 100 degrees Celsius, no matter how much water is present. Similarly, at 4 degrees Celsius, the density of water is 1 gram per milliliter, regardless of how much water is present.
Okay, if you look at now this example, in intensive property, if you change the volume, there's also change in the mass, right? Like here, it's 25 milliliter of water. It's around 25 grams of water also. This one is 100 milliliter of water. It's become 100 grams of water. There is a changes because if the amount involved in the present are changes already, that's why we call it intensive property. While extensive property, While intensive property, even you changes already the amount of a substance, but doesn't change, no? That's why property does not depend on the amount that present in the substance. That's why here, is it 25 or 100 volume, no? 25 ml and 100 ml of volume, still the boiling point is the same. Even the density are the same. So boiling point, the melting point, density are intensive property, while volume, mass are extensive property. Okay. Now, physical property is a characteristic that can be observed or measured without changing the identity of a substance. Melting point and boiling point. Okay, that's why these are physical property, no? Melting point and boiling point. Boiling point is a characteristic that can be observed, measured without changing the identity. Physical change is a change in a substance that does not involve a change in the identity of a substance. Example, grinding, cutting, melting, and boiling. This one is melting point, boiling point, no? Is a physical property of a substance. Okay? While physical change is a change of a substance that does not involve a change in the identity of a substance. Even you grind them, it's still the same, no? The identity of a substance. Even you cut them into small pieces, still the same, the identity of a substance. Even you melt them, still the same. But as in physical property, the melting point and the boiling point is still the same, right? Even you make different shapes already by grinding, cutting, melting, and boiling. Okay. A change of state is a physical change of a substance from one state to another. Change of state. What is the states? That like the liquid, gas, and the solid, right? Solid, liquid, gas are the states. Okay. We have states of matter. We have solid state, liquid state, and the gas state, and we have a new one here, we call it a plasma. Okay. Now, in the solid state, matter has a definite volume and definite shape. So if it is solid, like the ice, right? Solid ice, solid ice have a definite volume and definite shape. Okay. And then in the liquid state, matter has definite volume but indefinite shapes. Okay. And then in the gas state, matter has neither definite volume or definite shape. I will explain again, no? Okay, solid means to say, because solid have a definite volume, you can see if it is rectangular volume, right? Okay, the shape. Okay. Now in liquid state, it follows the shape of the container. That's why indefinite. Now whatever the shape of the container, that will follow. If the container is cylindrical, the liquid becomes cylinder also. Okay. Now, while in the gas state, the matter has neither definite volume or definite shape. Okay. No definite volume but no definite shapes also, because it's follow the shape of the container, and you can compress gases, no, in the same tank, right? By doing hiring, the pressure become high. Okay. And plasma, what is plasma? Is a high temperature physical state of matter in which atoms lose most of their electrons, particles to make atoms. Okay, it's a high temperature physical state of matter which atoms lose most of their electrons, particles to make up atoms. We call it in plasma states. I give you an example in the plasma state. If you see in the what happened in the inside in the television or in the CRT. Okay. We know already liquid, right? Okay, to make a more, so you can see some visual here.
Solid, liquid, and gas. A solid has definite volume and definite shape. A liquid has a definite volume but not a definite shape. A gas does not have a definite volume or shape.
You see, this one have definite means fixed volume and fixed shape. Here, fixed volume, but the shape is not fixed, depending on the shape of the container. Here, no fixed volume, no fixed shapes. Okay. Now you look at this example of a solid, liquid, and a gas.
A solid has definite volume and definite shape. The particles of a solid vibrate in fixed positions and are held in place by strong, attractive forces between them. A liquid has a definite volume but not a definite shape. The particles of a liquid have a range of movement that allows them to slide past one another. A gas does not have a definite volume or shape. The particles of a gas move fast enough to overcome nearly all of the attractive forces between them. Gas particles move independently of one another.
Okay, do you understand now? This is solid. Yeah, we have pack, right? Because have a definite volume and have definite shape. Liquid have definite volume but no definite shape. It's only following the container here. That's why they're losing up their molecules here now. And the gas is very very far from each other, the molecules. So an example of the gas. Okay, very basic. Okay, now water in three states. We already water is a compound, right? It's solid, it's very compact, right? In liquid, they're losing up already the molecules of water, but in the gas, very far to each other. This one is one molecule, right? One molecule. This is one molecule. Here, the molecule are packed together in the solid state. Okay, we're done already. I want you to answer this. Now, I send this in your Google Classroom. This file. You will answer this one. There is you can read this one here, what we discussed today, and then you can answer 1 to 5. This is the last page. This is the 5 one here. There is a 1, 2, 3, 4. You look at the reading check. Example number 4. The question here: list the 3 common states of matter. Then give example of physical change involving ion chemical. Okay. This is your homework, and then you can type here, or you can take a picture again, screenshots, and send it back to me. Okay? Do you understand? Students? Hello? Hello? Understand? Hello?
Yes.
Yes.
Okay. Okay. I think some of the classmates that didn't attend this class now, but they have the YouTube that I sent. They can watch there. And I think next time you need to send to me your email so that we can able to go inside the room, no? This suit. Okay? Do you have any
Okay.
questions? Huh? Do you have any questions? Huh? Ramida,
No.
Masuchanya,
No, no,
Matsui.
no.
You have any questions? You're watching the cell phone, right? Those watching the cell phone, I cannot see the camera. Only Discord is. I saw now. You're using two. I think two. Okay. Okay. Thank you so much. I send you this one. Maybe this document I will send also in the line. But look at in your Google class, in your Gmail. No, I send this also in your email, into your Gmail. Okay. Thank you so much. If you have questions, you can chat me anytime. Text to me to the line. Okay. Okay. Have a good day. Goodbye.